Namaskar. In this video, we'll be solving question number 7, question number 8, and question number 9 of ICSE 9th Laws of Motion exercise 3C. So, starting with the numerical number 7, that is, a force acts for 10 seconds on a stationary body of mass 100 kg, after which the force ceases to act. So this happens to be a slightly difficult question and is often given in the exams. So here what happens is a force acts for 10 seconds on a stationary body. That means the body which was not moving. The mass of the body is given as 100 grams, and after 10 seconds the force stops to act. The body moves through a distance of 100 meter in the next 5 seconds. So in another 5 seconds it moves 100 meters. Calculate the velocity acquired by the body. So here we would write the given data, that is mass is 100 kg, time is 10 seconds, u is 0, and the distance is 100 meters in next 5 seconds. So I would be using v is equal to u plus at to get the final velocity. But there is a problem. We do not have the acceleration. So I consider the acceleration to be a. So 0, that is the value of u because the body was stationary in the question, plus a into time is 10. So we get v is equal to 10a. Now what we would do is we would take this 100 meters in the next 5 seconds. So for next 5 seconds we will be assuming uniform velocity. So when we assume uniform velocity for the next 5 seconds, I would be using speed is equal to distance by time, or displacement is equal to velocity into time, where s is displacement. Remember, s is displacement, s denotes displacement and not speed. So displacement is equal to velocity into time because it is uniform velocity. If it was if the velocity was increasing or reducing, we would not have used this formula, but since we have assumed it to be uniform velocity, that is the reason we are using displacement is equal to velocity by velocity into time, which comes from the formula velocity is equal to displacement by time. So displacement we take it as 100 because it moves 100 meters in the 5 seconds, and time we take it as 5 seconds, and the velocity I substitute it as 10a, which we have got from equation 1. So we get 100 is equal to 10a into 5. So here we get 100 is equal to 50a. So a will be equal to 100 by 50. So that happens to be 2 meter per second square. So we found out the acceleration to be 2 meter per second square. Now what we can do is, we have the acceleration as 2 meter per second square. We can substitute it in equation number 1. That is v is equal to 10a, and that would give us final velocity. So v is equal to 10 into a is 2. We got it here in equation 2. So v is equal to 10 into 2, that is 20 meter per second. So we got the final velocity to be 20 meter per second. Now the second part of the question asks acceleration produced by the force. So we need to find the acceleration produced by the force. So here we have already found that acceleration produced by the force in equation 2. As we can see here, a is 2 meter per second square. So this is already solved. And then magnitude of the force, that means the value of the force. So we can use F is equal to m into a, where m is 100 kg and a we found out to be 2 meter per second square. So that gives us 100 into 2, that is 200 Newton. Now this was a slightly difficult question. Do pause the video and repeat it if you would like to see it again. So getting into the eighth question. So that is, figure shows velocity time graph of a particle of mass 100 grams. So mass is given as 100 gram moving in a straight line. Calculate the force acting on the particle. So we can see here it is a velocity time graph, and in velocity time graph, if the particle is moving in a straight line, that means it is uniform acceleration. So at any point, if we divide velocity by time, we would get the acceleration, and then we can do F is equal to m into a to get the force acting. So mass was given as 100 grams. Since it is not in SI unit, I convert that to SI unit. That happens to be 100 by 1000. So that is 0.1 kg. Now I have written, since the graph denotes uniform acceleration, here as I told you, in a velocity time graph, if there is a straight line going upwards, that means it is uniform acceleration. So acceleration, I have just taken it as velocity by time. So that happens to be 20 by 5. So that gives me 4 meter per second square. Now, as we know the value of acceleration and we know the value of mass as 0.1 kg, we can use F is equal to m into a. That gives us 0.1 into 4. That gives us 0.4 newtons. So the force acting is 0.4 newtons. Getting into numerical number 9 of exercise 3C. A force causes an acceleration of 10 meter per second square. So acceleration is given as 10 meter per second square in a body of mass 500 grams. So m is given as 500 grams. Now this is not in SI unit, so 500 grams we would have to convert it to SI unit. Then what the question has asked is, what acceleration will be caused by the same force in a body of mass 5 kg. So we would be finding out the force from these two given data, that is the acceleration here and the mass here, and then we would be using the same value of force and finding the acceleration for this mass. So I just write the given data. A1, that is acceleration for the first part, is 10 meter per second square. M1, that is mass for the first part, is 500 grams, which is 500 by 1000, that is 0.5 kg. The second mass is given as 5 kg, and we need to find the second acceleration. So first I would be finding the force from the first two data. So F is equal to m1 into a1. So m1 is 0.5 kg, 0.5 into a1 is 10. So 0.5 into 10, that gives me 5 newtons. And then the force remains same. So a2 will be F by m2. This again comes from the formula F is equal to ma, where a is equal to F by m. So a2 will be equal to F divided by m2. Now we would be using the same force which we have got it here. Since it is given in the question what acceleration would be caused by the same force. So the same force will be written here, F. So that is 5 divided by m2 is given as 5 in the question. So 5 divided by 5, that happens to be 1 meter per second square. Hope you guys have liked the video. Do share it with your friends. See you in the next video, in which I would be doing from question number 10 onwards. Dhanyavad.